Hello everyone, very good afternoon to all. Welcome to today's webinar on vehicle particulate emission measurement. I am Shrikant. I am a sales and application engineer at Tescon Systems India. Our company for over 25 years has been providing research instruments and technical support for instrumentation which are used for various industrial and environmental studies. Tescon is a leading distributor of high-speed digital video cameras for recording rapid events and other unique systems and facilities for research on vehicle safety. Tescon provides research equipment to perform engine emissions testing programs like size and chemically resolved characterization and exhaust particulate matter and VOC measurements. Currently, our instruments have been used in various campaigns and in industrial research in India to measure various safety parameters and atmospheric research as well automotive research. Also, we continue to expand our automotive instrumentation and real-time monitoring capabilities. I would like to introduce today's presenter, Mr. Peter Lamberts and Oscar Iviano, business development personnel from our principal company, Dekati. Dekati is a Finland-based company. So, Peter will provide us an overview of engine exhaust emissions and their types. And after that, Oscar will tell us about applications like blow gas and brake wear measurements with the help of Dekati systems. During the session, if you have any questions, then please put it into the chat box. At the end of this session, we will have question and answer session. So we will try to cover all your questions in there. Thank you again for joining us. I request Peter to start the session. Welcome, Peter.
Thank you, Shrikant. And also on behalf of myself and my colleague Oskari, welcome to this webinar. So we are happy to see a lot of you attending this this presentation. So today we will talk about Dekati solutions for automotive particle measurements, and there's several topics to be handled. Our purpose is that we give a short, or say a broad overview about several applications in the automotive sector that can be handled with Dekati solutions. And Dekati has been working with the automotive sector for a long time. So we have been supplying particle measurement instruments for the automotive industry since 1994. Dekati is as well is a member of the United Nations EC Particle Measurement Program Working Group. So we are also actively involved in new standards and norms related to particle measurements for automotive applications. Dekati devices are widely used in automotive industry, and one way to show that, so to say, is just having a look at all the published research articles related to automotive applications in which Dekati devices have been used, and those are over 2,700 right now. And we have a quite good reference base if we see, for instance, at the engine and after treatment development or emission norm compliance measurement, blow-by emissions. We have supplied to companies such as Ford, Toyota, Peugeot, Renault, Sandvik Off-Road, BMW, Bosch, Volkswagen Group, and many more. Also for related to engine development, for instance, lubricant and filter development, we have supplied devices to BP, Total, Exxon. More recently now, when brake wear measurements have become more important, we have been working together with companies such as Brembo and ITT. So we have really, we can look back at a very broad established customer base. So moving forward, we want to show you this graph, which shows as well as two graphs showing a little bit like the, let's say, the relative amount or contribution of several emission and automotive emission sources. So there is, of course, the traditional emission sources like diesel and petrol emissions. Here in the left graph, we can see that. But then at the lower end, we see there's brake wear, road abrasion, tire wear, and road transport resuspension. So what we want to show with this graph is that we see, at least in this is for England, of course, but it's a general trend. So we see a steep decline in engine emissions, but at the same time, the relative amount of non-engine, such as brake and tire, are becoming more important. And well, the graph at the right basically shows the same trend. And just extrapolating to the future, it's clear that non-engine emissions and non-engine emission measurements will become relatively more important in the near future. So then first, we'll look at the solutions that Dekati offers for engine exhaust emissions. So we can distinguish two big groups in our users, and there are, let's say, compliance measurements, which means that users who use our equipment for testing to check whether engine emissions are compliant with certain emission standards. And at the other side, there are non-compliant setups, and these are setups that are more used for R&D purposes. So for, as we show here, like for instance, for engine development and optimization, or then for after-treatment system development and optimization. We have different setups for the non-compliant, and we'll get back to the compliant later on. But starting with the non-compliant setup, we have 5 big groups. So first one is like the pre-after treatment system, where we measure particles directly after the engine. Then we have post-after treatment system, which measure particles after the after treatment system. And of course, if we combine these both, we can see what's possible, namely checking system performance of the after treatment system itself, so before and post after treatment. Then we have CVS, or partial flow dilution, while we are measuring volatiles, or then the same, so constant volume sampling, CVS, or partial flow dilution without volatiles. So both are possible depending on what's the study intending, so including volatiles or not. And then the last is onboard PEMS RDEs, or real driving emission measurements. So our main, let's say, instrument, the LP Plus, which has been around as long as Dekati, so for more than 25 years in various versions, is a really good all-around R&D instrument, especially for vehicle exhaust measurements, and that's why we want to highlight it here in particular. So the LP Plus and its variants make it possible to give a very clear indication about like size distribution, either in terms of mass or particle number. In the heated, so the high temperature version, the LP Plus can also be used to measure exhaust directly from the tailpipe without dilution. And that's, so far, it's the only instrument capable of that. So since the LP Plus can measure down to 6 nanometers, it's also an instrument that's suitable for the future. So it's really suitable as a long-term investment, since even if in the future regulation would go down to from 23 nanometers down to 10, the LP Plus is ready to cover that. It's also an instrument that's widely used for measuring fuel and lubrication, particle emissions, and as we have said, like to study after treatment system efficiency. So back to the different setups that we offer for the non-compliance measurement. So the first that we want to highlight here is like pre-after treatment directly from tailpipe, or say directly from the engine. So after the engine, we have typically very high pressures, high temperatures, and high particle concentrations. So for that purpose, we have this combination setup in which we have our D300, which acts as, let's say, pre-dilution system, and it's also used to, let's say, cope with the high pressure fluctuations that we see post-engine. So the D300 combined with our dilution system, the E-diluter, or its more advanced solution, the version, the E-diluter Pro. So the E-diluter will do the dual stage dilution. So first hot dilution followed by cold dilution to reduce the sample temperature to close to ambient, make it suitable for measurement by the LP+. And so in this case, again, LP+ is the preferred instrument, which is also available in a high resolution version. The high resolution version here gives a more detailed size distribution than the standard LP+, but both instruments can be used depending on the purpose. So if we move on from the engine to the after treatment, so now we are post after treatment. Here, of course, we have already lower pressures in the exhaust systems. Also, the temperature is slightly lower. Also, the concentrations are specifically lower since we are measuring post after treatment. So a lot of the particles have been trapped in the after treatment system. So for this purpose, we have basically two options to offer. First one is the high temperature LP, which, as I said earlier, can be used for direct measurement without dilution of the hot exhaust gas. So a high temperature LP Plus can handle temperature of up to 200 degrees C, which is suitable for most post-after treatment measurements. Or alternatively, we can, since we don't have the high pressures anymore, we can leave off the D300, which we had before the after treatment system. So in this case, the combination of E-diluter with LP Plus is certainly suitable. Then moving forward, if we want to do, and then we are at the tailpipe. So if we do either constant volume sampling or partial flow dilution sampling, we have two possibilities, again, same as we have seen earlier. So either we use the high temperature LP+, or then the combination setup with E-diluter and the LP+. So what we can do here is that if we want to measure with volatiles, we can either switch off the heating of the LP+ and measure, let's say, cold. So we will not have like evaporation of the volatiles. Or in case of the E-diluter, we can like switch off here, as I said. So the E-diluter has hot and cold dilution, so we can do the measurement without hot dilution. In the other case, if we want to remove volatiles, we can, in both cases, use the heated system, so put the heaters on, and by so evaporate all volatile matter. So the same instrument setup can be used for both measurements. Then the last word for non-compliance setups is about onboard PEMS measurements. So again, here we can use the high temperature LP plus for direct measurement at the tailpipe, or then in case we want to use, and that's already a more compliant setup, then if we want to have a compliant setup for RDE purposes, so we can use the setup that's shown here, which has basically a pre-dilution, let's say catalytic stripper and a heated probe, combined then with, for instance, a particle number counter system. So these are different setups that we have available for non-compliance measurements. If we move then to compliance measurements, of course, as you all may know, I mean, there's worldwide two big ways or two major ways how to measure, and first is based on particle mass, and the other is based on particle number. So if we look at measurements that require a particle number measurement, so these will always require a particle number counter. But then at the, let's say, dilution or sample conditioning side, we have several instruments that can be used with a particle number counter. So the first ones are here the DEET-100 and eDiluter Pro. So these are both certified for several compliance measurements, and the various standards are mentioned here. If we look more at the particle mass measurements, one instrument that's been used for that purpose is our Dekati E filter, which is basically a standardized gravimetric filter holder combined with a real-time measurement module. So we have the gravimetric filter that collects the particle mass on the filter, at the same time combined with a real-time module, which allows to monitor the measurement real time. And these instruments are used, well, a lot in the States, where there's still a lot of particle mass standards, but also for, let's say, in other parts of the world where, for one reason or another, particle mass is the preferred measurement method. Then soon to be released, not yet here, but it's a new RDE instrument, or Dekati EPNC. So it's a kind of first mentioning of this instrument. We will release this later on this year, but then you will certainly see more about that later on. So that was an overview of the engine emissions, and now Oskari will continue with the blow-by gas emissions.
Okay, hello everyone. Good afternoon. My name is Oskari Vainio, and I will then continue first with the blow-by gas emissions. So let's start by just briefly introducing what is defined to be the blow-by gas, which might be very familiar to many of you, but let's go through it quickly. So blow-by gas is formed when gases from the combustion chamber leak around the piston rings. So as you can see here, it's a very basic image of a combustion engine design. So the combustion happens here in this chamber, which is and most of the exhaust after the combustion has happened exits obviously through the exhaust valve, but this piston and the piston rings are not completely leak proof, which cause some of that combustion gas always to go into the crankcase. And in the crankcase you have the crankshaft rolling, and there's the oil sump at the bottom. And obviously when you have some of the combustion gas entering the crankcase, there has to be some way to also let it out. So basically it is being let out via a breather tube. And there are a couple of ways to then deal with that. And blowpipe gas, which is the gas that enters first from the combustion chamber into the crankcase, and from there on forward, that is mainly oil droplets, because there is obviously a lot of oil and oil mist inside the crankcase. So when it combines with the oil vapors here in the crankcase, it consists of mainly oil droplets. And as I mentioned, then there is a breather tube going out of the crankcase, and there are two basic ways to lead the gas out. So there is the option of closed crankcase ventilation, which means that the gas is being let back to the engine air intake. So it's a closed system where it goes back here into the intake valve and into combustion again, the same gas. But then the other option is the open crankcase ventilation, where it is just usually then filtered and goes into the atmosphere, or is being then led into the exhaust tailpipe eventually. And related to this crankcase ventilation, basically there's always some kind of a separator in the breather tube to catch the excess oil from the blowpipe gas. And in terms of particles, the blowpipe gas has very wide particle size range, because it has the oil droplets in it, but then it also has the soot particles coming from the combustion gas. Concentrations before separation or filtration are high. Mass is counted in milligrams per cubic meter. Temperature is around 80 to 100 degrees, and the pressure is slightly elevated, but not too much, usually in the sample inlet zone in these measurements. Concentration range is also quite wide, because this application is usually about studying the filtration efficiency. So there has to be measurements before and after the filtration to find out the size distribution in both cases. And these properties promote the application definitely for the high temperature LP+, because it enables the measurement from the high temperature without any dilution. Also, if the filtration is very efficient and the concentration after the filtration is low. So basically, and there is it is not just a straightforward thing that you just want to find out how well the filter works just to make better filters by themselves, but there are different types of aims with these studies being done with the LP+ units around the world. So when developing these closed crankcase ventilation systems, where the blowpipe gas is being led back to the engine intake, the filtration is very, very vital, because when there's a turbocharger and intercooler involved, the modern turbochargers, they are very delicate and they cannot withstand a lot of dirt or oil. So the filtration has to be super efficient in order to prevent the turbocharger from breaking down under the burden in these closed crankcase ventilation systems. And then with the open crankcase ventilation, where the blow-by gas is not being led back to the engine intake, it is still very important to have good filtration, because these blow-by gas emissions are contributing to the regulated limits that of the vehicle legislation. So even though the exhaust gas going through the main exhaust valve is treated very carefully, it could be that if they don't filter these blow-by gases well enough, they can then unfulfill the limits if the filtration is not good enough for PN or PM, depending on the regulation. Also, the filtration reduces then the contamination of the engine compartment. And obviously, in both cases, efficient filtration means less oil consumption for the engine. And obviously, that is always important for the engines to not keep losing the engine oil. And in most studies, as mentioned, the particle size distribution is then measured upstream and downstream of the used separator. And also here are some customer references from this area. AGCO, Parker, Hannifin, Caterpillar, Donaldson, and there are others as well. And there is also standard for these blow-by gas filtration systems, and the LP Plus is a solution that is in accordance and fulfills the requirements of this standard, which is also one reason why so many customers in this field are using it. So in the standard, it states that the particle counters can be optical particle counters, but also other counters that are demonstrating good correlation, such as aerodynamic particle counters. And LP Plus size segregates the particle by their aerodynamic size. Also, the size range that has to be covered is 0.5 microns to 10 microns in aerodynamic size. And they state actually in the standard that the technical advantages of using aerodynamic particle counters is well recognized. So in the past, it used to be that the measurements in this field were done with these optical particle counters, but it has become more and more clear that the aerodynamic size distribution measurement actually has some major benefits over the optical ones, which I have shown, which can be definitely seen from this picture, for example. So there's the capability to measure down to much smaller particle sizes compared to optical instruments. So in these graphs, there's two example size distributions. These are actual LP Plus data, mass size distribution and number size distribution from blow-by gas measurements. And this red dotted line, or the square, indicates the optical measurement size range, the size range that the optical counters can detect particles. As you can see, if you are looking at the particle mass size distribution, you will definitely not see all the mass when you are measuring the blow-by gas size distribution, and even more so when you're looking at the particle number size distribution, you will miss most of the particles, which is obviously not good when doing, for example, R&D for the filtration systems. Also, the users in this area and customers that we have been discussing, they tend to like to keep the sample temperature at 80 to 100 degrees Celsius, and there aren't that many real-time instruments that could do this. Basically, the high temperature LP Plus is the only one then capable of keeping the high sample temperature and measuring straight from the high temperature without lowering it in the size distribution, and then being able to get the aerodynamic size distribution. And to wrap up the blow-by emission measurements, here is the most usual setup that we have provided for these measurements. So it's a high temperature LP plus, which was already also shown by Peter, and it can be then combined with one heated Dekati diluter, because in some cases it needs a bit reduction in the concentration when measuring upstream of a filter. So this can then take the sample at desired temperature, usually around 80 degrees Celsius, and with the sintered collection plates compared to the smooth ones, you can do very long measurements without any need to clean the instrument, because this can collect a lot more particle matter compared to the smooth analysis plates. Okay, I will then continue with covering one other topic. This is then a non-exhaust application, the brake wear emissions. As you know, and as was mentioned by Peter, engine exhaust emissions are already quite widely regulated, but for brake wear emissions, the first emission regulations are being prepared now, and probably will be published in about 1 year from now. They are still under being processed, but what we already know, and what is the reason for these regulations, that the brake wear emission PM corresponds to about 10 times the tailpipe emissions from a modern vehicle. The brake wear emission, the process how the brake wear emissions are formed, the particle emissions, is a complex process. The materials are very complex in the brake wear industry, and the test conditions and aging of brakes have a lot of effect on the emissions as well. So there are a lot of different kinds of variables, and the LP Plus instrument family is ideal for these measurements, because the brake wear emissions, the particles have a very wide size range. The number size distribution is usually dominated by the smallest nanoparticles, but then if we are looking at the PM10 particle mass, that is being dominated by the coarse particles. And small particles are mostly caused in high temperature braking events, whereas the coarse mass here in the upper LP plus stages comes from the mechanical friction. So the wide size range, possibility to measure in real time, because also the brake wear testing is usually done with the similar drive cycles as in engine emissions, is important. There's the possibility to analyze volatility also with the brake wear emissions, and because of the complex materials, the possibility to collect samples for analysis is a very good benefit. So you can collect also while you are doing the real-time measurement, you can collect the sample from each of these small size bins here, and then after the measurement you can take them for further analysis. And here's one example setup and some data about the measurements we did with an brake manufacturer ITT in Italy. So they had this brake dyno. They because the brake dyno is not yet also regulated all the details of that, but basically the principle is always the same. There is filtered clean air going through the dyno, and then there's the brake rotor, the brake assembly here, and the clean air is being led through the braking rotor here and then led into this channel, and there is isokinetic sampling in the channel, and that sample after the isokinetic probe then goes to the measurement instruments. Here we had LP+, and then we had E-filter, and then we had a CPC condensation particle counter to get some comparison data between these instruments. CPC was by air modus, and Cyclone was used to cut the over 10 micron particles. Here's one photo of the setup, including the E-filter and the LP+. And the first graph here shows the LP+ concentration with the blue line, CPC number concentration on the orange line. Brake events are the step functions shown with the gray line, and the E-filter current reading is shown with the yellow line. So we were able to see these braking events with each of the instruments, and the LP+ and CPC number concentration correlated well. Also, the brake temperature can be seen here in the graph on the red line. Here's another graph from the same measurement showing also the numbers and mass size distribution gathered with the LP+.
Okay, thank you, Oskari. And then the last point that we want to cover today are tire wear emissions. So again, one in the non-engine emission category. So as Oskari mentioned, brake wear has got a lot of attention in recent years, and to the point that there's no common standards for brake wear measurements. And as going forward, we see that the next step in automotive particle measurements will be definitely tire wear measurements. So as I've shown you in the first slide of the presentation, so tire wear is also a big contributor to total vehicle particle emissions, and we see now that there's interest from, say, tire manufacturers to look into this matter, also from let's say lawmakers' side. We see that there are initiatives taken to move toward also standards for tire wear emission measurements and also tire wear emission limits. So there is already some proposals that in the future tires will have like also a kind of environmental label that will indicate like how much they contribute to pollution by particle emissions. So we see that that there's certainly interest in this field, and of course from our standpoint as particle measurement device manufacturer, we're also heavily involved in what's happening now. Brake wear, as Oskari mentioned, is already a very complex process, and so is tire wear. So tire wear, okay, we have a contact of a tire, which is a compound of a lot of different substances, and we have this compound in contact with, of course, road surfaces, which are also in many types and variants. So the emissions that are generated when tires are basically in contact through friction with the road surfaces are really quite complex. So there's, of course, in the emissions, or in the emitted particles, we see partly tire material, we see dust, we see also new chemical compounds that are generated in the process itself. Then, of course, there's a lot of parameters that influence the emissions, such as the amount of contamination or dust on the road surface, the way of driving, so drive cycles, cornering, so all the forces that are acting on the tire, and as I said, of course, the road surface. Again, we come back to our, let's say, our standard workhorse, the LP Plus, especially in the high resolution, so the HR version of the LP Plus, which shows like size distributions in a very detailed level, is very suitable for tire wear measurements. Again, just as in brake wear, we are facing a very wide range of particle sizes that we have to measure in real time. The fact that the LP Plus can also collect the material that's generated in the tire wear process is very important, because what we want to, since there is, we need to afterwards determine the amount of matter that's generated by the tire itself and that's generated by the road surface. So onboard testing, is it feasible? So because I know why we want to talk about onboard testing. So at this phase, as usual in a kind of development process, so the first step of going towards standard for tire wear emissions is that we first think the ultimate goal is to have a bench test. But before we can set up a bench test, we have to define a correlation between what's happening on the road and try to simulate it on the bench. So the first step, where a lot of activities are going on now, is to do like onboard, so real driving testing, to see what kind of emissions are generated by tires when driving on the road. So here, as I said, the LP Plus is the ideal instrument. We have the real-time data, and we have also the analysis of the collected material, so we can define what part of the emissions comes from the road and what comes from the tire. We have been participating ourselves in some first trials in onboard tire testing, where we had, and on the picture on the left here, the LP Plus, which is, well, we have then a pump also inside, so pump LP Plus, which takes then a sample via a collection mechanism that's just behind the tire. So by that we can, during the driving, collect material and see the different dynamic patterns, which is shown on the following slide. So in this trial, we had a car driven by professional test drivers on a closed track. And because this was a first trial, so the aim was to generate as much emissions as possible by driving also as let's say, driving as fast or harsh as possible. So they were on a test track done 2 50-minute runs, which was like about 10 laps. The tires were weighted before and after each run. The weight loss per kilometer was 5.8 grams. Of course, this was quite driving on the edge, but still. Then new data even suggests that premium tires can emit significant amount of emissions, so of particles, even during normal driving and cornering. During this trial, we also looked, also because for us it was the first time to use the LP Plus in this configuration, so we looked at how repeatable the data are and found very repeatable data between different runs. As you can see in the right side, so by using the, say, having professional drivers who did the same lap in a consistent way, we knew that let's say, dynamic behavior of the car was quite similar during laps. And we can also see that the particle emissions were very, very, within a very close boundary, so the results were very repeatable. So as I said, this is still in its infancy, how to say, but I think for many tire manufacturers, it's I think still a few years ago there was not a lot of interest, and now the interest is booming. So I think this is certainly something to be aware of, and I think for tire manufacturers, it's certainly something they have to be starting involved in. So well, that was our presentation. So I hope we have given you a good and a broad overview of what's possible using Dekati instruments in the automotive industry, and we'll be happy to answer a few questions.
Peter, there is a question from Mr. Sachin. He is asking about, is it possible to collect samples from
Yes,
EMPF
that's
for
certainly
further
possible.
chemical analysis?
So the LP Plus has different size fractions where we collect particles in different sizes. So we do the particle collections on special analysis plates. And after the measurement, these plates can be taken off and the material collected for various kind of microscopic or electron microscopic research or analysis.
Okay. Are there any options in these plates? Means that you, while presentation, you will discuss about sinter plate.
So we have basically
Is there
we have
any
two
other
types of plates. So the let's say what we have our standard analysis plates. They make it possible to do chemical or microscopical analysis later on. So they collect the material in a way that's easy for further analysis. And then on the other side, we have our sintered collection plates, which are more used for applications where we want to measure a long time, but without the need for later analysis. So that's the basic difference.
Okay. There is another question from Mr. Nagarajan. They wanted to know about are there any legislation on the emission of carbon particulates from tire wear?
At the moment, there is no such regulation yet. I mean, I think at the moment, as I said, like let's say the target is to go to a bench test, like with the brake wear. But at the moment, before going to a bench test, we first need to know what material really comes from tires, and then later on we can replicate it on a test bench. But to my understanding, at the moment there is no yet a kind of limit level for certain tire emissions.
Okay, there is another question from one of our attendee. They wanted to know the challenges in the measurements. Means right now, whatever are the measurements are at fixed place. Is it possible for instantaneous measurement of weight?
So I think the question is like whether the measurements can be done on board. Yeah.
During
So as we highlighted in the presentation, so for most applications we have done also on-board measurements. So the instruments can be taken on board. So then you need the measurement instrument, of course, the sampling instrument if required, and a pump, and then do the measurements while driving. So that's perfectly possible.
Okay. And also that Mr. John wanted to know that is it possible to measure all the parameters during vehicle under running condition, or there are some limitations?
Well, all the particle parameters can be measured during the running condition. Yeah. So and of course it's also depending on what kind of other parameters that need to be collected, but at least everything was related to particle size distribution. So in terms of mass or number concentration, everything that's related to the particle measurement can be monitored and recorded during vehicle running condition.
Yeah, I could also point out and add one thing related to this, that the sample conditioning systems we provide, for example, the eDiluter Pro system, they are also very versatile in a sense that you can have in a setup the eDiluter Pro, then the diluted sample can go to LP+, but if you need to have some gas analyzers or other instruments, you can connect multiple instruments into this one dilution system and then spread the same sample for many instruments too.
Okay, there is another question asked. Means Ms. Mohammad Abul want to know that how to measure the dilution levels while blowback gas and fuel dilution is the same.
It depends on the circumstances, but with the LP plus, the need for dilution is very quickly measured, because with the LP plus you get the result in real time, so you can immediately see if the concentration is too high or low. So it enables you to then, and if you have the eDiluter Pro, for example, you can choose the dilution factor between 25 to 225. So it can be set online for the good level for the instrument. But also the good thing about the LP Plus is that the concentration range is very wide, so you don't usually need to keep changing the dilution factor all the time. But let's say in general, in blow-by gas and for post-after treatment measurements of exhaust, usually with LP Plus you don't need any dilution on, or then perhaps only a little bit of dilution.
Okay. There are not more questions from viewer, but I just wanted to know about that maintenance. Is there any routine maintenance required for the sinter plate or that collection plate? And is there any specific time period for that?
it is highly dependent on the particle concentration that is being measured. But just as an example, if you do measurements where you don't need the post analysis, so you don't do chemical or microscopic analysis afterwards, then you can use the sintered collection plates. And with those, well, just as an example, we did measurements of ambient air here in Finland. We had the instrument running for about half a year and without any cleaning, and the instrument was still running well. So with the sinter plates, the collection times are very long, and but also I can give you one example from the smooth collection plates, the analysis plates, where you can do the post analysis. You can, for example, run break wear measurements using a break wear test cell several days without replacing the foils, for example. So it is not something you would have to keep doing all the time unless you do some. Usually this, if you need to clean it often, then you can do it. Then fix the problem by adding some dilution.
Okay, there is one question by Mr. Omkar that there will be no repeatability in RDE test due to versatile parameter like driving behavior. How it will be included in the emission test results?
Well, it's of course the whole RDE topic came up, especially in Europe after we had the Volkswagen scandal. So after that, there's been a big drive to push to also do not just laboratory tests, but also check the emissions during driving. There are now, and of course, it's a valid comment that like how you can make sure that it's repeatable. So there is a certain, at least for let's say engine emissions, so there is a certain, let's say there are certain boundaries or parameters during a certain test drive that you need to have. Then is X amount of flat road, X amount of hill with X amount of engine load. So there is a kind of window that you need to follow. And then let's say the purpose is that, so at the moment now is that you compare laboratory emissions or the homologation emission levels and then the RDE emission levels. And at the moment it's such that your real driving emissions can be not know by heart the number. I think at the moment it's still they have to be less than, the difference should be less than, if I'm correct, 20%. Now the target is to reduce this. So now there's still the RDE emissions can be a certain percentage higher, but in the next standard they want to reduce the allowable difference, so they will reduce it furthermore. But of course, it's true. It's a challenge, like to do these repeatable tests. But if you see, I mean, the European RDE requirements, they are. I mean, you can find them online on the side of the European Union, for instance. So it's quite well defined, like how you do an RDE, let's say, test cycle. So also to try to keep it as repeatable as possible.
Okay, I think we are having few more questions, but and the time of that webinar is over, so we will answer them separately through their mails. And I thank you, Peter and Oskari, for the fundamental explanation during the gas emission and all the equipments of Dekati, and how it is important to measure the engine efficiency and the facts. So Thank you all the attendees as well, and thank you again to
Thank you
Kia
for
and
having us.
Oscar.
Thank you, everyone.
Bye bye.